Now we're going to section 6.4, factoring perfect square trinomials and the difference of squares. So this is really a method of making your factoring faster if you can recognize certain patterns. You don't have to be able to recognize these patterns, but if you can, it makes your factoring faster. So let's look at these special products. Our first special product is a plus b times a plus b. If you multiply those using FOIL, you will get a squared plus 2ab plus b squared. How do we recognize this special product? Well, if the first term is a perfect square, it's something square like 3 squared, 5 squared, x squared. And if the last term is a perfect square, then you should ask yourself, is this one of these special products? It could be that it's a plus b times a plus b. It could be that it's a minus b times a minus b. The only difference being plus 2a for the first one, minus 2a for the second one. So if our first and last terms are perfect squares, we should think about whether or not this might be a special product. Our last one is a difference of perfect squares, a plus b times a minus b. You can recognize this one because it will be the difference of perfect squares, a squared minus b squared. There is no middle term. If you have the difference of perfect squares and there is no middle term, you should think about, is this special product of a plus b times a minus b equals a squared minus b squared. Be careful though, because a squared plus b squared cannot be factored. It is prime. So let's see if we can use these special products to enable us to factor more easily and faster. So x squared plus 2x plus 1. Doing it our normal way, we know that we will just put our double set of parentheses. It's x times x. There's only one way to factor 1. It's 1 times 1. Both signs are positive, so it has to be a plus 1 times a plus 1. And sure enough, that gives us 1x times 1x. Add those together and you get 2x. So that's right. That is the way this is factored. Now, had we recognized that it was a perfect square here, a perfect square here, we might have thought maybe this is a special product. And the middle term is 2 times the square root of the first and last term. But, I mean, we got it using our FOIL in reverse method, so it's okay. 9 plus t squared minus 6t. You know, we can't really factor this unless it's written in descending powers of one of the variables. There's only one variable here. So the first thing I want to do is write this in the proper order, t squared minus 6t plus 9. Let's do our double set of parentheses. It's t and it's t. It's plus 9, so the signs have to be the same. It's minus 6t, so they both have to be minus. 9 is 3 times 3. And sure enough, that's our solution, t minus 3 times t minus 3. It's the first term is a perfect square, the last term is a perfect square. We always look for common factors first. Do you have a common factor here? Let's factor out that x. We have x squared minus 18x plus 81. This is a perfect square. This is a perfect square. The middle term is minus. You can either use the FOIL method, or if you recognize the special product, it's x minus 9 times x minus 9. Don't forget to put that common factor of x out front. Oh, look at this one. Is there a common factor? I don't think so. But I noticed that 64 is 8 squared, 49 is 7 squared. Is this a special product? We can use our FOIL, make it 8 and 8. How about we try 7x and 7x? It's got to be a minus. A minus times a minus is a positive. So that gives us minus 56x. Minus 56x. That's minus 112x. That's our answer. W squared minus 81. This one I really do use the special product. I think, oh, okay, that's W squared minus 9 squared. That's the difference of perfect squares. We can use our FOIL method, so you have to have W times W for your first. So that's W squared. You want your last to be equal to minus 81. 9 and 9. It's got to be a minus 81, so it has to be a plus and a minus. There is no middle term, and when you do your outside plus your inside, they cancel each other out. You get 0. So W plus 9, W minus 9. That's our solution. Oh, look at this one. Once again, that's the difference of perfect squares. That's a squared minus 4 squared b squared. The difference of perfect squares. So it will be a plus 4b, a minus 4b. So that'll give us a squared minus 4ab plus 4ab. Those will cancel each other out. Minus 16b squared. So that's our answer. X to the fourth minus 16. Gosh, this seems like perfect squares. I know 16 is 4 squared. What about that x to the fourth? Can we write that as something squared? What goes in the parentheses? An x? What about an x squared squared? Yeah, that's x to the fourth. So it's a difference of perfect squares. So it factors into x squared minus 4, x squared plus 4. That's the answer. Y squared plus 25. I mean, we can try if you have y times y. If you put plus 5 and plus 5, the problem is the inside and the outside will give you plus 10y. That won't work. If we put minus and minus, the outside and the inside will give us minus 10y. That we don't have a middle term. If we change it to plus and minus, that's not going to give us a middle term. It'll have 5y minus 5y, but the last term will have to be minus 25. You can't factor this one. It's prime. The difference of perfect squares can be factored, but the sum of perfect squares is prime. That's all for this section.